Find a quadratic polynomial with a given number as the sum and product of its zeros respectively. So now here we have alpha times beta as under root 2 and alpha, wait, sum is first, so yeah. So we have alpha plus beta on the first and alpha into beta on the second, which is 1 by 3. And we know that alpha plus beta is minus b by a and alpha into beta is c by a. Minus b is the coefficient of the x term and a is the coefficient of x square term and c is the constant term. If you do not, or if you are not clear with that, great great option to go back and check the other videos which I have made on the same topic. Okay, now here what they have said is we need to find the quadratic polynomial using the sum and the product of its zeros. Now how we can do that is by using those same equations, I won't call equations, but those properties of how two zeros, if you add two zeros, it's the coefficient of x minus the coefficient of x by a, and so on. So now let's we have written this. Now let's write under root 2 is minus b by a. Now we always go with the assumption that the equation is of this form, bx plus c. Okay, it's always of this form. We take that as our base and move on. Now the next one is alpha into beta is 1 by 3, so that's 1 by 3 equals c by a. And now here we like there can be so many of these kinds of polynomials, quadratic equations, but now here what we do is we assume that a is 1. We take a as 1 and then we get minus b as under rooted 2 and c as 1 by 3. Now here we have taken everything as plus, and if we have minus b here, the minus goes over there and basically becomes minus under root 2. So for the coefficient of x we have to write minus under root 2 and the constant term will be 1 by 3. So I'll write that will be x square plus, I mean minus, I just showed you, minus under root 2 x plus the coefficient term. Okay, now the thing is, you might be wondering that there might be so many other polynomials, say if a is 2, say if a is 3. Now for that, what we do is this polynomial is in its lowest terms after taking everything common. So after everything taking common, the common term which is k. So after if any question is given like this, and we get the answer, we usually put it in a bracket with a k, because if say a was 2, I'll show you that as well. I'll erase this. Say if a was 2, okay, say if a was 2, we're taking a as 2 this time, okay. And now what's gonna happen is, if you notice, we're gonna get minus b as minus 2 under root 2, so that's b, and our c will be 2 by 3 and our a will be 2, right? Now the equation formed will be 2x square minus 2 under root 2b and plus 2 by 3c. And now here if you notice, we can take 2 common out of it. Now if we after we take 2 common out of it, we'll be left with x square minus under root 2b plus 1 by 3c, which is basically the same thing. So that's why this thing we have here, this 2 is written as a k, because a can be any number. Now let's do a similar question in which 1 by 4 and minus 1 by 4 are given as the sum and product, and also to tell that these are taken from exercise 2.2 question 2. This one is the second part and this one is the fifth part which we're doing. Okay, now let's see here. So we are giving the sum is 1 by 4. The sum is 1 by 4. So the alpha plus beta is 1 by 4, which is minus b by a. And alpha into beta is minus 1 by 4, which is c by a. Now here let's go with the assumption that a is 1. We'll take a as 1, so we'll get our b as minus 1 by 4 and our c as well as minus 1 by 4. Now the answer we'll get is now we'll get our answer as, now we know b, we know c, we know a. We just need to put it in this plus c. We need to put it in this. So a is 1, so that's x square. B is minus 1 by 4, so minus 1 by 4x. C is minus 1 by 4, so minus 1 by 4. So that's going to be the equation we are looking for. And also we have to put it in a bracket with k over there.